Hello guys, this is Expert Funda and you are watching on YouTube. So let's understand today lead code question. So today we have 1020 number of enclave, right? So we will go and see this question. Okay, so 1020 number of enclaves we have given, and you have given an matrix of m cross n binary matrix grid, right? Means it is we have given in 0 and 1. Now it is saying that where 0 represents a C cell and 1 represent the LAN cell, right? Where 0, that is you can say water, right? C cell, and where 1, there is a land, right? Now it is saying that a move consists of walking from one LAN cell to another adjacent 4 directionally, right? So if the 4 directional means what? If this is a point, right, either will go this or this way, right? So if this is the current position, if we'll go this way, this will become what? For x direction it will become +1, right? If we'll go here, this will become -1. Similarly for this one, if we'll go up, we will do 1, right? And if we'll do here, it will become -1, right? Like this. So this can be either 0, this can be either 1, or this can be either 1 or 0, like that. So these values can be different. Okay, so a move consists of walking from one cell to another adjacent 4 directional LAN cell of walking of the boundary of the grid, right? And then return the number of the LAN cell in the grid, right? LAN cells in the grid for which we cannot walk of the boundary of the grid in any number of moves, right? So it is saying that we have to return the number of LAN cell in the grid in which we can say for which we cannot walk off the boundary of the grid in any number of moves, right? So we'll see that. Okay, so as you can see, we have given here, right? So how many LAN cells we have, right? So as you can see here, we have given this array in which these grids value have 1 1 and 1, right? So these grid, if you see, we cannot move of the boundary of the grid in any number of moves, right? You can say here we also have, right, like that. So what happened, there are 3 1s, that is enclosed by zeros, right? These are enclosed by zeros, these 3, as you can see, and 1 s we have here, right? And that is enclosed because it's on the boundary, right? That's on the boundary. And so that total 3 LAN cells we have for this grid. Similarly, coming to example 2, in which we have given this one. Okay, so first we have given 1 here, LAN cell 1 here, 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 and here. Okay, and if you see, right, if you see here, all ones are either on the boundary, right, either on the boundary, right, or can reach by the boundary. This can be reached by the boundary also, right? And that's why there is no other LAN cells that is rounded of the water, right? Now coming back to the constant, we have m given, so row length and column length, and then you can say we have given m and n, it should be greater than equal to 500, less than equal to 500. Either it will be 0 and 1 because binary numbers will be there onto the list, onto the grid, right? Now coming back to our theory, right? So this is what we have given, and number of cells we have to get find, and for which we cannot walk off the boundary of the grid in any number of moves, right? Any number of moves. So this question is very, very important because asked in the Google, and we have given hints also here. So can you move this problem as a graph, right? It is saying either you can go to DFS or BFS, right, or union find, and create n into m plus 1 nodes, where n into m nodes represent each cell of the map and 1 extra node to represent the exterior of the map, right? Next, it is saying that in the map add edge between neighbors of the cells, right, and add extra edge between the exterior line of the boundary, and we will return the answer of the node and not reachable to either the exterior node, right? So hence you can read and you can understand that what is saying that, right? So it's saying to go to the graph, either use DFS, BFS, or union find, right? So we are going to see the depth first search, right? So here in the problem section, right, actually the problem is asking us to we have given 2D grid, right, and with each cell of the grid that represents either a water or a cell that is denoted by either 0 or 1, right, respectively. So our task is to return the number of land cell, right? We have to return the lander, we have we have to return the land cells for which we cannot walk off the boundary of the grid in any number of moves by moving left, top, bottom, right, like this, right? And so left, top, right, bottom, right, 4 directions. So what we will do, we will see the problem, that what problem states that we cannot move in all the 4 direction, left, top, right, bottom, right, any directions, right, which leads us to model the problem as a graph, right? And we can treat the 2D grid as a undirected graph. A land cell in a grid correspond to a node in such a graph with an undirected edge between the horizontal or vertical land, right? So if we begin to traverse in this graph from the node that are land cells on the boundary and keep on tracking or keep on traversing, you can say, as long as we will visit all the land cells from the, you can say, which we can reach the boundary. So land cells which aren't visited with 1, right, or which we cannot reach the boundary, right, in any way. So the count of these unvisited cells, right, would be our answer, right? So we will traverse DFS, and to traverse over the land cells, right, we'll use DFS here. And the DFS, right, is very important algorithm, and we actually doing regularly DFS. So we use recursive function here to explore all the nodes as far as the possible, right? We'll go to all the branches of this one, right? So upon reaching the end of the branch, we backtrack the previous node and will continue the next branches. So once we encounter an unvisited node, we will take its a neighbor node, and if it exists as a next node, right, on this branch, recursively we call the function and we'll take the next node as a starting node and we'll solve the sub problem, right? So let's understand. We will perform DFS from every unvisited node, right? And how we'll do, let's understand. So this is the initial grid we have given, right? So if we are going to take the root node of the trigger DFS, right? So first we will put our root node, right, and we will traverse all its node, right? So actually we will perform a DFS from every unvisited land cell at the boundary, and we'll treat it as a node, right? So first of all it will come as a root node, right, and we will traverse all the nodes that are present in the connected component of that starting node, and we'll mark them as a visiting, right? So we'll start from here to here, right? But what we will found here as a root node. Okay, so what will happen, we will perform a depth first search that every unvisited land cells we have, right? So after that, what will happen, after completing the DFS, right, traversal, we counter the number of cells that are not visited, correct? So what we'll do, so we will start from here. I'm go back here. I'll always start from here, the root node, and this is our root node. From here we'll traverse all its children node. We got our node. After this we'll see is there any connected node, right? So there is no connected node, so we'll start with the root node that trigger this one. This is our next root node, and we'll continue this one. So now you can say this is the node covered by the DFS, right, we have. So number of unvisited land cells in this answer will be, right, 3 we have, right? So we cannot visit these 3 here, okay, because see, we can visit this one, we can visit this one, right? We can also visit from here, we can also visit, right? But what we cannot visit, because see, here is water, 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 here is water. So we cannot visit this land, right? And that's we have to find out correctly. Okay, Now if we'll talk about the implementation, right, what we should do here, right, we know that we are going to do the DFS, right. So we have to find two things. The first, m and n. M, row and column, you can say number of columns and number of rows. So if this is our number of column and this is number of row, like we want to do the we want to create a grid like this, and then we will do the traversal, right. And for that what we will do, we will mark similar as a visit, as a node, right. We'll create a visit node, and or you can say visited node we'll create, and we'll move we'll mark if this is visited, we will mark true. If not visited, right, we will keep it like that only. So initially we'll put some value there if you want, otherwise we'll take the boolean and we'll mark it as a false already. Okay, so what we'll do after that, we will iterate all over the cells, right, of the grid of the boundary. For every cells, right, ij, let's suppose we'll go I and j, right. So what we will do, we'll check if it's land cell or not, right. Land cell, is it land cell or not. If it is a land cell, right, it has not been visited, right, yet, then we'll do the DFS traversal of that node, you can say, and we will use the DFS function to perform the traversal. For each pass, let's suppose we will take xy grid as a parameter. The xy parameter represent the in the you can say row and column of the cell from the DFS where should begin, right. So we'll start with the I and j cell, and we'll traverse the pass x and y in the grid, right. And if the cell xy is out of the boundary, right, we'll do that. We'll check out of the boundary, or is it water already visited or not. We don't do anything, and we'll return. Otherwise what we will do, we'll mark it and we will visit again, and we'll recursively call the DFS, and we'll go to its next branch, like that we'll do, right. So we'll see that. Let's compile this code so that it will will not consume much time, right. So let's understand from here and do the we'll understand the implementation, right. So first of all, what we have given here is let me come back to here. Okay, so first of all, the function we have given, and we have to do implementation, right. So that what we will have given in the solution, we have given this class number of enclaves, right, we have given. So we'll get our column, we will get our rows, right, and then what will happen, we have visited, right. So we'll take a visited of 2d of the same size, right, because m and n we are passing, number of row and column we are passing. Now what we will do, we'll traverse all the you can say column first. So in the first column, what will happen, if I grid at I and the 0, that is equal to 1, and if not it is visited, then we will pass the DFS utility, and what we know that why we are using the DFS utility, right. So DFS utility, actually it will what it will do, we are taking a you can say DFS traversal, right. We will use this DFS utility function to perform the DFS traversal, you can say, right. So for every pass for every cell, right, what we will do, we will pass some value, right, into the grid, right, and those values parameter represent the row and column of the cell, which it will again do some DFS utility function, right. So actually DFS will do it will check out of the boundary of the grid, or it is water cell, or it is visited cell, right, those things it will check, right, and when the when it will happen, it will mark that this is visited or not. So what we'll do we'll see later. Now similarly we'll go to the last grid, right, and we'll see similarly build the DFS, right. So only we have to see the starting, because we are passing this is the first column, so we'll pass this value like this, I 0, because 0 is the first column, right, m and n. If we are talking about the last column, right, what will be pass, n minus 1, and then m we will pass. Okay, coming back to here, we'll take similarly we'll first row and first column we will pass, in which we will take I 0 and I grid at 0 and equal to 1, and we'll mark the visited, right, visit at 0 and grid, right. We'll do the implementation, same will pass for the last row, will use m minus 1, I m n will pass, like, and there is we'll take a number of cells, right, and we will count if it is equal to 1 and it is not visited, we'll update our number of cells and we'll return the number of cells here, right? So actually this part we have to do, and for doing this one we are doing all the things, right? So let's understand now DFS, right? So DFS will pass x, y, m and n, right? So there is two x and y things, and m and n we already know. Then we will take grid and we'll take grid and boolean visited, okay? Which this is the condition where we are touching the boundary, right, or not, that we'll find. So if x is less than 0 or x greater than equal to m, means out of the boundary, or it is less than 0 means x is out of the boundary, you can say. And if if y is less than 0 or if y is greater than equal to n, it means y section, right, the direction of y, right, and the cell direction, and cell direction x and cell direction y, if it is out of the boundary we will return, or if it is greater than 0, right, or if it is not visited, then we also return, we will not do DFS. Now think about if it is you can say if it is if it is visited, now if it is visited, right, if it is grid equal to 0 and if it is visited, right, and if it is visited we will mark it true, if it is not visited mark it true, then we'll find its direction, x direction. You can say we will go to what, 4 direction we have to go, right? The first you can say left, top, right, bottom. So for all direction, for x and y we have to take, and for all those directions what we will do, we'll go to the because we have four coordinate value, right? So for that what we will do, this is 0 minus 1 1 0 0 1 1 minus 0, right? So for all those directions we'll move to this one, and the DFS will internally it call it's all the 4 direction. X will add its x value and y will add its y value, and grid's value will be remain same, so that we will traverse all the its grid, right? And we'll similarly we'll update our what we can say our DFS utility function will traverse in all the direction. So that's all we have to do. Actually we have to mark true or false, right? Now coming back to here, right, after doing these two operations, right, first by the columns and second by the row, once we are done with that, then we will call this one, right, number of cells things, will check if it is visited, if it is grid equal to 1 and not visited, then we will update our number of cells, and finally we will return number of cells. I think you got it, right? So what I'll let me zoom out. So that's all we have here, as you can see. Let me submit this one. So this is the solution we have for today, right? So we are going for number of row and column m and n we have given, right? And we are traversing, we are DFS utility will for all the row and column, as you can see here, right, m and all the m we are also going, right? And so that it will take o m into n times o of m into o of n times, right? So because we will perform all the operation visiting all the nodes in the worst case scenario, so we will take o of m and o of n, right? And similarly we are taking visit, right, and we'll store all the row and column into the visit, right? And we also do the you can say traversal, right? So in the worst case every node will get added. And that's all for today. The space complexity and both will remain same. So SC and TC is O of MN, right? M into N we can say. Thank you guys, thank you for watching this video.